I think there's so many different scenarios where microgrids and energy storage come into play. So I think it really depends on what you need.
This is Energy Cast, and I'm Jay Downhauer. Today we're talking about microgrids, the big solution for our future energy needs. I'll admit I didn't know much about microgrids going into this interview. As a project manager in the transmission sector, I've always thought of microgrids doing what we do on a smaller scale. I've seen sophisticated transmission equipment nestled into sleepy little towns. Unless you are on a deserted island or in the deepest jungles in the Amazon, why do you need a microgrid? My guest explains that yes, that may have been true 10 years ago when all microgrids were literally off the grid. But today, her company is developing more grid-connected systems, which address the needs of modern users. From what I heard, it sounds like microgrids specialize in the ability to manage a lot of inputs dynamically. One example might be a location that has a lot of renewable generation. Maybe there's a lot of homes with rooftop solar. What if folks drive electric vehicles and charge them different times of the day? And what if they live in areas prone to reliability challenges like wildfires in California? Grid-connected microgrids can manage that through a combination of energy storage and control software systems. We discussed a similar setup with Wärtsilä in episode 75. It's a delicate balance of assets that might be best handled on the local level. It's also my belief that microgrids will expand to the point where they become almost indistinguishable from, well, the grid. My guest today is Maxime Gavi, head of Grid Edge Solutions for Hitachi ABB Power Grids. Those in the industry will be very familiar with ABB, the Swedish-Swiss power company with roots going back to the 1880s. In late 2018, ABB's Power Grids announced it would enter into a joint venture with Hitachi, which began in July of this year. I was familiar with this because we use these products in transmission. With the new organization, Maxime says the two companies are still exploring ways to leverage the partnership. One of those opportunities lies in Hitachi's strengths in the software space. I was able to catch up over Teams with Maxime in Switzerland. I hope you enjoy my conversation with Maxime Gavi. We're here with Maxime Gavi, head of the Grid Edge Solutions business for Hitachi ABB Power Grid. And Maxime, I've been upgrading and improving the transmission grid for the last 3 years here in the Carolinas. So I have to ask, why would a developed country need a microgrid?
Well, that's a really great question, Jay. We've been doing microgrids at Hitachi ABB Power Grids for more than 30 years. And we did start way back when with remote communities and remote sites to provide access to reliable power and also sustainable power. In developed countries today, some of the same challenges are also bringing up microgrids again. If you look at grid resiliency, you could like grid reliability, but also sustainability. Those are also all the elements where we can apply the key components of a microgrid for the power grids in developed countries.
What by definition is a microgrid? It always implies to me that there's no power supplied from the outside, no transmission or distribution lines feeding in. It's completely isolated. Is that how we should think of it?
Well, the definition of microgrid has evolved quite a bit. What microgrid is where you have multiple generation and multiple loads under the same control system, either grid connected or off grid. And if it's grid connected, then it has to have the ability to island itself when needed and run independent of the grid. So clearly, a majority of the microgrids in the past were off-grid, again, for remote communities, for remote mines, industrial applications, as well as critical load application where there was no grid to connect to. But what we have seen over the last few years is really the expanding application of grid-connected microgrids where you are connected to the grid, but if there is a need for you to disconnect, whether it's intentional or it's because of natural disasters or for security reason, you disconnect, you would still be able to run independently. And a key component there, of course, is to be able to do that seamless transition from a grid connected to off grid. And this is where we see quite a bit of applications that are expanding for microgrid.
And this is where I think it's interesting, this kind of hybrid idea where you are somewhat connected. And you brought up the examples of maybe a natural disaster like wildfires in California. I believe in transmission, they have something called CMI, customer minutes interrupted. Usually those numbers are pretty low. So how often would that happen where you would need to cut off from the main grid?
It depends on where you are and what are the challenges that you're facing. Clearly, we see bushfires in Australia. We see fires in California, hurricanes in many parts of the world, specifically also the eastern part of the United States. These are all occurrences that would enable or create an environment for a microgrid. It could be outages for minutes or hours or days. Another area where I would say microgrid would come in is where you have high integration of renewables that are required. We're seeing more and more renewables that are entering into the grid. And one of the key advantages of a microgrid is where you can actually use a microgrid to maximize the penetration of renewables, and you're not curtailing the wind or the solar generation. An example of this is the site that we did, Electronet, which is a distribution utility in Australia, where by leveraging our energy storage and control and automation technology, be able to reduce their outages from 8 hours down to 30 minutes in the first 6 months of the operation. And this was a very large wind farm, distributed solar, that was all coming together. And the beauty of microgrid is that it can adapt to different situations and to different applications and to different circumstances to solve the problems in a wide range of characteristics.
And that's a great point. And it kind of feels like maybe renewables is one of the reasons why we're hearing a lot more about microgrids. Does it make better sense to manage a high concentration of renewables on a microgrid level as opposed to on the grid on a wider basis? Help us understand that better.
There's a really key component of microgrid, which is storage and also the control technology. And when you're talking about integration of renewables, you're using the same components from a microgrid in this space to be able to maximize the integration of renewables and be able to manage those intermittencies that are inherent of these types of generation. When we went from looking at working with small microgrids and off-grid microgrids to really doing large-scale microgrids, large-scale integration of renewables into the grid, we leverage the same technology. It's our power store technology, which is our battery energy storage system, along with our eMesh portfolio of automation and digital capabilities that fundamentally is managing and controlling and optimizing the entire ecosystem. It's not just what I would call a microgrid that helps the integration of renewables. It's the key components of microgrids that now are able to address the broader topic of integration of renewables, especially as we see more and more larger scale renewables that are being deployed. And frankly, they're also being deployed much further away from the point of consumption, and they have to be transmitted and go through the network to get to the customer. In addition to being able to manage the distributed energy resources, such as solar rooftop, in the entire network.
This is a really nerdy question just because I work in transmission, but with these microgrids, how high voltages are you playing with? In my personal experience, they've dealt with voltages as high as 500 kV. Distribution is below around 12. How much voltage are we dealing with on a microgrid level?
I would say, again, it depends on the application. We deal with applications where you have your microgrid and energy storage behind the utility meter. You also have it in front of the utility meter when you're doing large-scale integration of renewables. So I think it really covers a wide range. It's not one specific voltage that we would be targeting.
How do microgrids integrate with utilities? The question I was originally thinking of was, what are customers' electric rates on a microgrid compared to regular customers? I'd assume one of the benefits of a regular grid and generation for thousands of people, as opposed to a lesser number, is the costs are more spread out. How does that affect the people who are living within the microgrid?
It really varies across the globe in different regions. If you think of a behind the meter microgrid and And when you have the assets, and your assets would be your generation, it would be your energy storage. Sometimes as we see more and more, we see electric vehicles, etc. So you have multiple assets that you're managing in a microgrid. Clearly, because microgrids generate power, you can reduce your cost of electricity through self-consumption. You also, the electricity markets where you can participate, that's where the term value stacking comes in, because not only are you using those assets for your own use, whether it's reducing costs, improving CO2 footprint, and providing resiliency, etc. Now you can also participate and leverage those assets in the power market and be able to do the value stacking and take advantage of that. The cost really varies depending on what's available to you in terms of the market participation, what your cost of electricity is, your access to renewable, and how you really are using the microgrid. But we're also seeing, frankly, more and more utilities who are really reinventing their business models, and they're participating in this space. Obviously, customer retention is a key topic for them. And so by participating and retaining those customers and offering them the same capabilities, they're able to also leverage those assets and also participate in that market. But going back to your initial question of how does the rate compare, it really depends on where you are and also what are the KPIs that you're looking at for the microgrid.
Maxine, you mentioned electric vehicles, and I actually had a panel that I did with Siemens and HDR Engineering back in January. And one of the things we were talking about was this massive amount of electrical consumption at the residential level with electric vehicles, and what happens if an electric vehicle goes up gas station. Does that gas station right now have enough electrical service to run a high voltage recharge station? I'm wondering if you're seeing a lot of interest in microgrids, what Hitachi's offering for managing EV penetration, because I think those are a lot of challenges that I think that utilities are just now really facing, and we'll probably have to face them pretty quickly.
Yeah, and that's a good question, because we are seeing obviously a large deployment of electric vehicles, and a key component of addressing the challenges that electric vehicles pose to the grid is really addressed with energy storage. So if you look at an energy storage system, it can remove load from a power grid, for example, or allow for deferment of investment for the grid. And if you look at the other things that they do is also reducing peak demand, which is especially important given that DSOs cannot predict the load because of the EVs, and exactly as you said, how many of them at the same time are going to be connected. This is definitely something that helps enable the EV deployment. The key component, again, goes back to the key components that I mentioned earlier from a microgrid, are the storage component, as well as the control technology, the automation technology, and the digitalization.
From a sales standpoint, in what situations do microgrids make the most sense? What is the easiest thing to essentially sell? Like, this definitely needs a microgrid as opposed to the alternative.
Gosh, Jade, it really depends where you are. If you go up to Gull Bay, Canada, and ask the community there who deployed a microgrid, and that reduces their reliance on diesel, and also they wanted energy independence and they wanted to protect the environment and have reliable power, that's a really easy case. If you go to Electronet, where they wanted to reduce the outages and not to have to curtail the wind generation and have quick payback on the assets that they had deployed, then that also makes a lot of sense. And that's also an easy case. If you are looking at a community, say at the end of the line, instead of adding to the transmission infrastructure to strengthen it, make sure they have reliable power no matter what, and you can actually do that with energy storage and control and automation technology, that makes a lot of sense there too. I think there's so many different scenarios where microgrids and energy storage come into play, and to make the case quite simple, I think it really depends on what you need. And this is what's really exciting about what we do. Yes, we started 30 years ago with remote sites, but the application have evolved so much, especially over the last 5 or 6 years, where it's really expanding to a lot of different areas. And frankly, when you look at IT, i.e. data centers, you look at smart cities, smart life, mobility, whether it's the utilities or the commercial and industrial sector, there are applications where energy storage and microgrid make a lot of economical sense. They also make sense from a sustainability perspective and also from a resiliency perspective.
Maxine, I like to talk a lot about developing countries as well, especially with renewables and possibly changing the model that's been used for decades here. What's been your exploration into microgrids in developing areas and also places like islands, places that don't have a traditional electric grid?
We actually have a lot of experience in that area. First of all, if you look at the islands, we have a large reference list, whether it's with wind or hydro or solar or a combination of all of those with storage, and really improving the power quality and resiliency of the power, but also improving sustainability, because for many of these locations, getting diesel for power, obviously, it's very difficult to get sometimes, and it's also very expensive, and it's not a sustainable source of energy. We have a lot of applications in Cordova, Alaska, in Australia, east of Europe on the Atlantic coast. We have several flagship island projects. One of them is Robben Island, where Nelson Mandela was incarcerated, and the prison is now a tourist attraction. Now we have a microgrid there where it has solar storage and with diesel as a backup. In terms of developing countries, we also have sites in several countries where providing access to renewable power. One of them is in Kenya, where we're incorporating storage and wind for a community, Marsabit community. If I may just add, this is one of the key areas that's also important to both Hitachi and also Hitachi ABB Power Grid. Hitachi's corporate message is social innovation for power and good. Power Grid's message for years has been building stronger, smarter, and greener power grids. So bringing them together, one of the benefits of this is being able to provide benefit for the broader social good. And our aim is for the next 30 years to bring electricity to the remaining almost 1 billion people who still don't have access to power or reliable power. That's definitely a goal to strive to.
That's very exciting. I always love talking about that. I think that could make the greatest difference, right?
I have to agree with you. And quite honestly, there are many aspects of what we do that excites me and gets you out of bed in the morning. But certainly being able to do something for the social good is really important.
Maxine, as much as we talk about renewables, I talk probably more about storage on this podcast. I know you're focusing on batteries for storage, but is there anything else that your team likes? Pumped hydro, something a little bit more mechanical maybe than chemical batteries?
One thing to keep in mind is we don't make the storage medium. Our technology is agnostic. We can essentially work with any type of storage medium, and we in fact have done so. Our installed base includes any storage medium that exists out there. From that perspective, we really look at the customer application, we look at the requirement, and then we match the storage medium and our solution to the customer application. Now, having said that, we've standardized on batteries, and the reason we've done that is because their cost has become much more economically viable. For majority of the applications, batteries are a viable option, both technically and economically. Although we've standardized on batteries, we can work with any type of storage medium, and we know there's quite a bit of new technologies on the horizon, and that's exciting. And we'll look forward to working with those as well.
In my role in transmission, we've used ABB a lot. How's the power grid portion of ABB changed since they were purchased by Hitachi?
I would say the only thing that has changed so far since the JV was established is the collaboration and really our access to Hitachi and the capabilities that they have. You're bringing the world top power technology company, which is Power Grids, and then you also look at the incredible digital achievements that Hitachi has done, and now bringing those together and really taking the innovation, access, and development to the next level. So from that perspective, I would say that's really the most significant change, the ability to be able to have access to each company's technology and customers and be able to support them together. And also, I think one of the other things that as we'll see, especially going forward, we will see a lot of developments in the market as it relates to policies, as it relates to business models, et cetera. It's also the ability of the two organizations really coming together and also bringing other key stakeholders to the table and really on focusing on the investment and leveraging the technology and the collaboration across the stakeholders. It's really going to be key in supporting a secure, scalable, and sustainable power grid as a whole.
What do you hope to gain most from this venture? I think when most people think of Hitachi, they think of electronics, smart devices. Maybe I know the company is much larger than that. What have been some of the gains that you've seen?
Speaking for Grid Edge Solutions, really having access to Hitachi's digital capabilities that really complements our automation and control technologies. It's also strengthening the footprint. Certainly gives us access to Japan, which is the world's third largest economy, where we have installations, but certainly it will strengthen our presence there, but also globally strengthening that footprint further. We're still in the exploration stage, so we're still getting to know each other's capabilities and also the complementary areas where we can bring those together and go to our customers and be able to further expand on the value proposition that we have for them.
Very good. Okay, Maxine, I'm going to finish with a lightning round of your thoughts on different energy technologies, starting with natural gas.
An option that be around for a while.
Crude oil.
Not on top of my list.
Nuclear.
Also another potential viable option for energy.
Coal, and I'll also add with carbon capture.
Not on top of my list.
Wind.
It will become even more economically viable and we'll see more deployment.
Solar.
Wonderful.
Biofuels.
A good option to be further explored.
Hydroelectric.
Sustainable and proven.
Geothermal.
Sustainable and proven.
Energy storage.
Absolutely a game changer in the energy transition.
Electric vehicles.
They're coming and we need to get ready for them because they will have a huge impact on the energy ecosystem.
Energy efficiency.
Definition has evolved significantly and has expanded.
And then finally, fusion power.
Don't know enough to comment.
That's how you do it, folks. Maxine Gavi, Hitachi ABB Power Grid. Thank you so much for your time.
A pleasure. Thank you for having me.
That was Maxine Gavi, head of Grid Edge Solutions for Hitachi ABB Power Grids, based in Switzerland. I want to thank Maxine for her time, as well as Megan Krause at Highwire PR for setting this up. You can find plenty of pictures on energy-cast.com, as well as on Instagram and Parler at Host Energy and Twitter at Host Energy Cast. All guests are sent the raw and completed audio the week of release. So far, no complaints. Be sure to leave us a positive review on iTunes. That gets the word out. Music was produced by Sean Stroop at Stroop Loops. That wraps up episode 98. Be sure to join us next week when we go one-on-one with the developer of the nation's first small modular reactor. It's the first in a series of panels I hosted recently. Until then, I'm Jay Downhauer. We'll see you next time.